Hi guys, my name is Werner and I'm going to talk about what is polynomial equations and inequalities in chapter 2. What is polynomial equations? Polynomial comes from poly means many and nomius in this case means terms, so it is say many terms. A polynomial equation can have constants, variables and exponents, but can never be divided by a variable. These are some of the examples of polynomials, and these are not polynomials. And take a look. Okay, what are inequalities? Yeah, this is the example of inequalities. Equal, not equal, bigger, smaller, bigger or equal to, smallest and equal to. Chapter 2.1, the remainder theorem. What is remainder theorem? When a polynomial function px is divided by a divisor, means x minus b, the remainder is p and b. And when it is divided by ax minus b, the remainder is p, b over a, where a and b are integers and there is a restriction for a, means a cannot be 0. Okay, this is an example for long divisions, and this is quotients, divisor, and polynomials equations, and this is remainder. Quotient form. What is quotient forms? The result of the divisions of a polynomial px by a binomial of the form x minus b. Yeah, this is an example. And for corresponding statement that can be used to check the divisions, px equal to x minus b multiplied by the quotients plus the remainder. Example 1. Apply and verify the remainder theorem. Used to remember theorem to determine the remainder when px equal to 2x cubed minus 3x squared plus 8x minus 12 is divided by x minus 1. Verify your answer using long divisions. Since x minus 1 equal to 0, the remainder p bracket 1 inside, and put the 1 inside and substitute it, and so you get an answer with remainder -5. Okay, by using the long divisions, we'll get the same answer as doing the method just now. Okay. For example 2, solve for an unknown coefficient. Determine the value of k such as 3x power of 4 plus kx cubed minus 7x minus 10 is divided by x minus 2 and the remainder is x. And for these solutions, we substitute the 2 inside the x and see that from here to here, from put this to here and this to here, you get a k, so that we find the unknown coefficient for k is -2. That's all, and I will talk about 2.2 factor theorem. What is a factor theorem? Okay, what if we calculate PB and it is 0? That means the remainder is 0, and x minus b must be a factor of the polynomials. When PB equals to 0, then x minus b is a factor of the polynomials. When x minus b is a factor of the polynomials, then fc equal to 0. Similarly to this, and there's a name for this. I will show you in next slide. Okay, the terms if and only if, IFF. It is a term that used in logic to say that the result works both ways. Here, both of the following are true. If x minus b is a factor, then pb equal to 0. Yeah, it is same. Okay. Yeah, for this integer zero theorem means x minus b the factor of the polynomial functions with leading coefficient 1 and remaining coefficient that are integers. And for rational zero theorem, where it's like ax minus b like this, and a is a factor of the leading coefficient of px, and b is a factor of the constant of px. For example, x cubed minus x squared minus 14x minus 24, we can guess the possible factor for 24 means like you times 1 and 24 together you get 24, you times 2 and 12 together and get a 24, and times 3 and 8 together and get a 24. Yep. Example 2. Factorize x cubed plus 2x squared minus 5x minus 6 fully. Okay, first we determine the possible factor first, and then we do it one by one. If the function is equal to 0, then it is a factor of the polynomial equation. So I try for 2 and it's get a 0, so it means that x minus 2 is a factor of these polynomial equations. Then we can use two methods to find the other two factors. Long divisions, syntactic divisions. First, yeah, this is a long division, and we get a quotient, and it means that x cubed plus 2x squared minus 5x minus 6, and we get a factor and another quotient behind, and this can be factorized into the smallest ones. So when this become to this and all together to become this, it means fully factorized. Okay, for the method 2, syntactic divisions, we wrote it down for the numbers behind here with a sign of coefficient down and label like this, and x here, and means you put 1 here, negative 1 here. For the first one you put it down, and for the second one, this one times this one and put it here, and you get a number here, and you this one times this one, put it here, you get a number. You do this for all, and when the remainder behind is 0, it means it is a factor of that. And we can do the factorization as similar as the method 1. Okay, for example 3, solve a problem using the rational zero theorem. So from this we can see that it is a rational zero theorem. First, let B represent the factor of the constant term 2, which are plus and minus 1 means positive and negative 1, and positive and negative 2. Let A represent the factor of leading coefficient 3, means these, which are positive and negative 1 and positive and negative 3. The possible value of B over A are positive and negative 1, positive and negative 1 over 3, positive negative 2, and positive of negative of 2 over 3. Okay, then test the possible value of 1 and we get 0, so therefore x minus 1 is a factor of px. Then we can use long division to factorize and use factorization to factorize fully. So we can see from here the same thing that we do previous example. Okay, that's all.